So we've got a little control panel here.
Good afternoon, I'm Dave Selinger, and I'm here to present my Computer Science 277 Experimental Haptics project, where my partner and I have built a 2 degree of freedom brake-based force feedback device. Here we have the construction. We've made it out of standard 1/4-inch acrylic machined using a laser cam. Here's a set of electronics to control the brakes. We're using a set of MOSFET transistors to take the input signals from the computer controller and apply a 24-volt power supply to the brakes in order to. Here you can see the PIC design brakes, which apply about 2 ounce-inches of torque, and a Hewlett-Packard 5500 optical encoder to read the position from each of the joints. We're running a Windows 2000 based control algorithm that has on its screen essentially a plane of motion, which is this blue plane, and a red dot representing the position of the end effector, or your finger, in the virtual space. You can see that as I move the end effector, which is this bar, back and forth on the robotic arm, that red dot on the screen representing the end effector, or your virtual finger, also moves back and forth. To demonstrate the basic force feedback, I'm going to load up a plane orthogonal to the motion of the end effector using demo 1 here on the software. And you'll see that as I move the finger into the virtual wall, or that vertical plane, the brakes will engage and stop the motion of the hand. Some more complicated examples are if we have a diagonal plane and we use what's called velocity control to determine the actuation of the brakes. You will notice that as I move the finger along this virtual plane, which exists approximately here, the brakes engage. A more complicated example would be a spherical shape or a circular shape. And as you can see, the brakes also are able to represent the shape and prevent the cursor from entering the center of the circle.